Dr. Michael. Thank you. We have your permission to record this talk and host it, right?
Yes,
Dr.
sure.
Thank you. So Dr. Hadley is Assistant Professor of Medicine, Cardiology, and Environmental Medicine and Public Health at the Icahn School of Medicine at Mount Sinai. He's also Associate Program Director of the Cardiovascular Disease Fellowship. He obtained his MD and MPH from the Harvard Medical School and completed his IM residency and fellowships in cardiovascular disease, as well as in advanced cardiac imaging right here at the Mount Sinai Hospital. He's an internationally recognized expert in climate cardiology with recent publications on the topic in Circulation, JACC, and BMJ. He also serves on the World Heart Federation's Air Pollution Expert Group and is part of Mount Sinai's Institute for Exposomic Research, whose mission is to uncover how lifetime exposures shape human health. I'm happy to say that Dr. Hadley has carved his niche in an institution where cardiology is so specialized. And we'd love to hear from you, Dr. Hadley, what you have to present to us today. Thank you for coming.
Absolutely. Thanks so much for the warm introduction. Let me try and share my screen here. Let's see. Are you seeing this now?
Yes, sir.
Yeah, let me go to presentation mode. There we go.
Yeah.
You can see okay, and you can hear me?
Yeah, it's perfect.
Okay, great.
Everything.
Okay, so maybe a little bit of a change of pace today, but I think something pertinent. You've seen, the headlines in the New York Times yesterday was about how we're expecting heat waves to break all records in the next few years, and certainly this has implications for health in general and cardiovascular health in particular, which is really my focus. I know this is a multidisciplinary institute. I'm going to keep it focused mostly on cardiovascular disease because that's what I'm most familiar with and where my research is, but I'm happy to try and answer questions about other systems as well. So I just have a few financial disclosures. Some of the slides I'm going to show today come from my consulting work for the World Health Organization. And this is an outline for the talk. This topic of climate change and health really is enormous. I'm going to try and focus on a subset of topics that serve as an illustration of this field, and I think how it's going to become incorporated increasingly into clinical practice. I'll start with a summary of where our planet's climate is headed this century, and then I'll give an overview of the risks that climate change poses to global cardiovascular health. I'll focus further on the topic of air pollution exposures under climate change, kind of as an example of one of these climate hazards. And then we'll talk about interventions for protecting populations, for protecting individual health, and the role of the physician and the patient-doctor relationship in all of this, and what this means to us as physicians. And my hope is that these examples will showcase this new field we're developing here at Mount Sinai of environmental cardiology. It's a field, I think, of really great opportunity for this century, and we'd love to get interested folks involved. So to begin, let's summarize. This is the current projections for climate change for this century. When you compare current global average temperatures to the pre-industrial average, we've warmed about 1.2 to 1.3 degrees Celsius, which is over 2 degrees Fahrenheit now, and that's due to greenhouse gases emitted from human activities. And this is projections going up to 2100. So let's think about where we might go from here. These different scenarios have been modeled by the IPCC and by a separate Lancet commission that corroborates these findings. So let's just start with the best case scenario, okay? If we get to net zero global emissions by 2040, then the world will still warm to about 1.5 degrees Celsius by the end of the century. That's going to lead to about a 400% increase in extreme weather events like hurricanes and droughts and floods. It'll lead to the degradation or the loss of most of the world's forests, reefs, wetlands, glaciers, sea ice. We'll see mass extinctions, widespread biodiversity loss. And together, it's estimated these forces will push several hundred millions of people into poverty and put over 1 billion of people at risk of displacement from their homes from climate hazards. And that's globally. In the United States, we're also going to see some changes. We'll see the frequency and intensity of heat waves increasing everywhere. The East Coast in particular will see more hurricanes, more heavy downpours and flooding, some sea level rise, inundation of the coastal cities. And the Western US will see more drought, more devastating wildfires like we've started to see the last decade. And these hazards in general in the United States and globally will affect the most vulnerable groups. This is really the best case scenario. So this tells us that we're past the point of just trying to mitigate climate change. We have to start thinking now about how to begin planning adaptations to what is going to be inevitable. And it's unlikely climate change will be contained at 1.5 degrees because to do this, we'd have to cut global emissions in half by 2030. But currently, emissions are still increasing year after year. So it's going to be tough to even make this goal. If you look at 2 degrees Celsius warming, this is where we start hitting tipping points where climate change accelerates and gets to crosses points where it would take thousands of years to reverse the changes. So for example, we could see the collapse of the great Antarctic ice sheets, which could lead to dramatic sea level rise. That also decreases the reflective surface of the Earth, and so it further accelerates warming. So other examples of these kinds of tipping points, like the melting of the Siberian permafrost, for example. If you look at 2.4 degrees, this is actually where the Paris Agreement is projected to take us. So you can see it's already past the tipping points. And that is if all countries keep their current commitments. Paris was a success in the sense that we had near universal buy-in, but there's no real enforcement mechanisms to hold countries accountable. And a lot of the promises made have yet to be implemented. There have been a lot of delays. And then if we continue just at a business as usual scenario, if we really don't do anything, then we get to around 3 to up to 4 degrees Celsius warming by the end of the century. And the fallout of this in terms of storms and drought and famine and infectious diseases and forced migration effectively would erase the last 50 years of global public health progress and lead to an estimated over 9 million annual additional deaths due to climate change. So it's my doom and gloom slide, but I think it's important to kind of have that as a background for how important this is going to be. So this has led the Lancet Commission to declare climate change as the top threat to global public health this century. And I'm a cardiologist, so I'm a little biased, but the cardiovascular disease still remains top cause of global mortality. And so for me, my research is kind of at the intersection of these two major threats. We think there's a lot of opportunity here, and that's really going to be the focus of the talk today. So let's talk about these pathways for how climate change causes cardiovascular disease. I'm going to run through 7 different climate hazards that threaten cardiovascular health that are supported by the current literature. And I don't have time to go through all the details of that literature, but I promise I will take a deeper dive on air pollution as an example. So first, extreme temperature exposures. Heat waves are going to increase under climate change. Currently, there's about 500,000 deaths annually worldwide that are attributed to heat exposure. The majority of those are cardiovascular deaths. A third of those are also attributed to climate change in the last 20, 30 years. Under a business as usual scenario, researchers are predicting about a 35 to 40 times increase in exposure to heat waves by 2100 globally, which would lead to a tripling in heat-related mortality as soon as 2050. How's that work? Heat exposures lead to this inflammatory procoagulant state that can be worsened by fluid depletion, which is associated with hemoconcentration, sympathetic activation. All of this together provides an environment that promotes atherosclerotic plaque rupture, clot formation, arrhythmias. And studies have found a consistent relationship now between short-term extreme heat exposures and cardiovascular mortality. as well as cardiovascular hospitalization, MI, and stroke, and activation of ICDs. That's heat. The next risk is water pollution exposures. So manufacturing, smelting, agriculture, different types of industry, all of these produce cardiotoxic pollutants. The most dangerous being lead, cadmium, arsenic, and mercury. And then storms and extreme rainfall and sea level rise from climate change increases the runoff of these pollutants into local water sources, where they contaminate drinking water, but also crops and fish and livestock that are relied on by hundreds of millions of people across the world, including in the United States. And the pathophysiology of those pollutants is complex, but it usually arrives at this common pathway of oxidative stress and inflammation and vascular dysfunction. So again, it promotes atherosclerotic cardiovascular disease, MI, and stroke. So if you just look at lead, for example, already is responsible for an estimated 800,000 cardiovascular deaths worldwide in 2019, according to the Institute for Health Metrics and Evaluation. If you want a nice review of how pollution affects the heart, I highly recommend this New England Journal article by Drs. Landrigan and Rajagopalan, who are both Sinai affiliated faculty. Moving on to vector-borne illness. So climate change will affect the distribution of these vectors of different infectious diseases. So there's the Ixodes tick, right, which carries Lyme disease. We're starting to see earlier seasonal activity and expansion to higher latitudes now into Canada and into Europe as well. The Triatomini insect that carries the microbe responsible for Chagas disease. We're also seeing it develop faster and feeding more aggressively at higher temperatures, and it's starting to migrate north. It's been detected now in the southern United States. The mosquitoes also are changing their distribution. The Anopheles nates mosquitoes, these are the mosquitoes that carry malaria and chikungunya and dengue, and we'll see the territories that they affect change. And all of these diseases have been associated with cardiovascular disease and other diseases, as you know, but we've seen an association between malaria and ischemic heart disease, myopericarditis, heart failure. There's a nice review of this, of malaria and heart disease, recently published in JACC that I also recommend. The next threat of climate change to cardiovascular health is malnutrition. And thinking about health in general, malnutrition is what the WHO predicts will be the largest health risk of climate change, because we're going to see a decrease in the yield and in the nutritional content of major crops and fisheries and aquacultures around the world that are nourishing billions of people. There's going to be a scarcity in whole grain micronutrients and fresh produce and seafood, all of which are known to have cardiovascular benefits. And then in place of those shortages, often you're going to see importation of more energy-dense artificial foods and associated increases in cardiometabolic disease. And as of now, those are on a business as usual trajectory. Those changes would be estimated to result in an additional 500,000 premature deaths worldwide. That's by 2050. And it's also, I think, important for any pediatricians in the office to be aware that this is a major impact on children. We're right now estimating an additional 25 million undernourished children by 2050 due to climate change, an additional 570,000 cases of stunting in children under 5 years old as soon as 2030. And of course, the childhood malnutrition also has long-term implications for health in general and increases your risk of your lifelong risk of cardiovascular disease. Fifth, I'll talk about mental illness. Not as much evidence supporting this yet, although the body of evidence is growing. Certainly, it makes sense. Storms and heat waves, wildfires, all of these climate hazards, displacement, forced migration, conflict, have been associated with anxiety and depression and PTSD and substance use, intimate partner violence, even Takotsubo cardiomyopathy, and anxiety and depression in general have been shown to accelerate atherosclerosis, and so we expect that this to worsen the burden of atherosclerotic disease. But we need more data to link climate change to mental health, to cardiovascular disease. And then the sixth threat I'll talk about is just the disruption of the public health system in general. So we're seeing this already around the world, where major storms and floods damage healthcare facilities. They reduce the availability, accessibility of healthcare workers. They may disrupt a lot of the essential services that support the healthcare system, like supply chains, access to essential medications, telecommunications, electricity, etc. And also hazards like drought and famine often may lead to the forced migration of populations, and those can overwhelm health system capacity for whichever cities settings are receiving those migrant populations. And then, when met with these kinds of emergencies, oftentimes, historically, health systems deprioritize the care of chronic illness. So things like, the care of cardiovascular disease, pulmonary disease, et cetera, may be deprioritized when these kinds of hazards occur. The WHO has done a lot of work surveying health systems around the world, and they've concluded that the vast majority of countries, including the United States, doesn't have an appropriate health framework to respond and be resilient to climate-related emergencies. And the last threat I'll talk about is air pollution, and this is where I want to take a deeper dive. So this is really the environmental risk factor that has the best data supporting a causal link between cardiovascular disease and exposure. And it's also the risk factor that has the most developed evidence-based set of interventions for protecting cardiovascular health. So let's dive deeper into air pollution. So these are just some numbers from the WHO, from IHME. Right now, air pollution exposures globally are responsible for about 7 million deaths annually. The majority of those are from cardiovascular causes. About 7 billion people are exposed to levels of ambient air pollution higher than what's recommended by the WHO guidelines, including all of us here in New York City. And overall, this makes air pollution the number 4 risk factor for mortality. You have hypertension, diabetes, hyperlipidemia, and then air pollution, and then smoking. So pretty high. And again, the relative risk of air pollution exposure may not be as high as something like smoking, but because 7 billion people globally are exposed, you end up with a higher total mortality. Deaths due to air pollution are expected to double by 2050. That's due to growing pollution exposures in industrializing countries, as well as the growth of wildfires and dust storms due to climate change. This chart shows the top 5 causes of death from air pollution exposure. You can see it's about a 50-50 split between cardiovascular and pulmonary disease. Cardiovascular deaths mostly driven by ischemic heart disease and stroke. Pulmonary disease driven mostly by LRTI, lung cancer, and COPD. And I'm going to talk about the mechanisms of cardiovascular disease in a minute. When you look at cardiovascular mortality specifically due to air pollution, about 3.5 million deaths annually worldwide, that's 1 in 5, are attributed to air pollution exposures. And when you look at severely polluted regions like India and China, it's upwards of 1 in 3 cardiovascular deaths that are due to that. In the US, it's more like 1 in 25 cardiovascular deaths can be attributed to air pollution exposure, or about 25,000. In New York, it's even better, 1 in 40 or 1,300 cardiovascular deaths. That's about the same number of deaths in New York that we had from aortic stenosis last year, which of course is a disease that we've directed a lot of resources towards treating. Let's talk about where this air pollution comes from. There's a lot of different sources. Of course, it varies by region. In big cities in the United States and abroad, the major source of air pollution is vehicular emissions, like exhaust and brake and tire wear. In more industrial regions like the Rust Belt here in the United States, major emissions come from coal power plants, from manufacturing. In more rural regions like West Virginia, Appalachia, or a lot of places in the rural developing world, the indoor burning of solid fuels for cooking and heating ends up being the major source of exposure. In developing countries, this indoor air pollution is responsible for 1/3 of all air pollution related cardiovascular deaths. And then the fastest growing source of air pollution globally are wildfires and dust storms due to climate change, which we'll talk about a little bit more. On top of this is also a climate penalty, where climate change actually worsens air pollution exposures that weren't necessarily due to climate change in the first place, because there's changes in heat and weather patterns that decrease the vertical mixing of air in the atmosphere. And so you get high pollution levels just kind of settling at ground level more frequently. And that also encourages the development of toxic secondary pollutants like ozone that form in the presence of these other gases. So overall, climate penalty is worsening exposures across the board. I want to emphasize the gravity of this wildfire smoke problem. We're not quite as acutely aware of it as the West Coast, but it's coming, and it's worsening every year. This is a satellite image of the 2020 wildfire season, and you can see this dense smoke just blanketing the entire American West and the 70 or 80 million people that live there. And then this smoke we saw, if you remember, traveled thousands of miles, exposed millions of people to hazardous pollutants. Here you can see in the 2021 wildfires, this dense smoke extending from the Cascade Mountains all the way to the Northeast, all the way to us. If you recall, at that time, if you went outside, you could smell the smoke in the air for a few days. Darkened the skies a little bit. It turned the sun red. And this is really a scale and intensity of air pollution exposures that we've never seen in New York in our nation's history, and it's going to get worse. So this is a map showing the expected change in wildfire potential globally through the year 2050. The United States alone has experienced a 5-fold increase in wildfires since the 70s, and expecting it to double or triple again by 2050, which would lead to about 80 million people annually in the US being exposed to hazardous levels of wildfire smoke. The other regions you can see, they're going to see big increases: Central America, the Amazon basin, Sub-Saharan Africa, Central Asia, Southern Asia, and Australia. And, this shows where the wildfires are going to happen, but the smoke doesn't respect international borders. It's going to cross oceans and continents, and it will become a growing global public health issue. All right, that's types of smoke. Let's talk about composition. There's a lot of different types of air pollution. We usually encounter them in this complex mixture. These are the common components that I've shown on this slide. And today, we're really just going to focus on particulate matter, because this is the pollutant that has the strongest associations with cardiovascular disease. It consists of these little microscopic particles that are a combination of carbon and sulfate and nitrate and dust and dangerous organic molecules. And then it's classified based on size. So you can see in the figure there at the bottom, the particles that are passing through a filter 2.5 microns in size. Anything that can pass through that is PM 2.5. And it's this PM 2.5 that's shown the strongest associations really with cardiovascular disease. And interestingly, it's also about the same size as a red blood cell. So pollutants that are small enough to fit through a capillary are also the ones that we see have the worst cardiovascular effects. Let's just orient ourselves to different levels of PM 2.5 exposure, because this is going to be important for the coming slides. So you can see across the entire US, we're averaging about 9 micrograms per meter cubed. And then the WHO guideline for maximum annual average is 10. The average annual exposure here in New York City is 12. Across the whole borough, it's actually a little higher in Manhattan. And then the WHO guideline for maximum exposure in a single day is 20. If you smoke just a single cigarette once a day, then your annual PM 2.5 exposure would be 22. Of course, you'd be exposed to a lot of other toxic chemicals in cigarette smoke, but just for illustration. And then if you start looking at more polluted regions of the world, the average annual exposure across all of Asia is 35, much higher than that WHO recommended level of 10. The most polluted city on Earth right now is New Delhi, with Dhaka about to pass it with an average exposure level of 225. Portland, Oregon, for the entire month of September 2020 during the wildfires was above that at 250. And then the highest levels that humans are exposed to come from indoor burning of solid fuels for cooking and heating, typically in a place that doesn't have appropriate ventilation. Here's just a map of PM 2.5 levels around the world. You can kind of ignore the Sahara here because that's just dust storms in unpopulated areas. But you can see the highest concentrations really are in Asia, in India and Bangladesh. And I think it's interesting to note that, at least in cardiology, we make assumptions about the burden of disease someone's going to have based on where they're from. And if someone's from Bangladesh or from India, and we're going to send them to the cath lab to see how bad their coronary disease is, we often expect it to be very bad if they're from those regions. There's some thought that that's due to dietary or cultural factors, but there's growing evidence that it's probably due to air pollution as well. And which is one of the reasons why if people from those areas have kids in the United States, they don't have nearly as bad disease. It's because the environment has changed. And if you look at the United States specifically, you can see that the highest levels of PM 2.5 are in our urban centers and also in industrial regions in the Midwest, in the Rust Belt. Los Angeles, historically the worst. They're getting better, but still the worst on a hot day in traffic in Los Angeles. Here's a figure that shows the distribution of PM 2.5 around the world on a logarithmic scale. You can see India and China really have the most people exposed to the highest levels of air pollution. The United States here is in blue, and that WHO recommended level for exposure is that first dotted line. So you can see the vast majority of the global population is far above the recommended exposure. Okay, so that's sort of the global burden of exposure. Now let's talk about mechanism and how air pollution affects cardiovascular health. So the research in this really started in the early 90s. This is the watershed paper really for this field. This is called the Harvard 6 Cities Study, published in the New England Journal in 93. It was a large prospective cohort study of over 8,000 adults from 6 US cities. They were followed for 15 years. And they monitored exposures to a variety of different pollutants from ground-based monitoring stations. And then they looked at different outcomes, cardiopulmonary mortality over time, and used a Cox proportional hazards model to understand the association between these exposures and these outcomes, controlling for a lot of other factors. And after adjusting for the covariates, they saw this clear linear relationship between exposure to PM 2.5 and cardiopulmonary mortality, with a hazard ratio of 1.37 between the most versus the least polluted study. And you can see how much our graphical software has improved since the 90s. There's been extended follow-up of this cohort now for something like 35 or 40 years, continuing to demonstrate this relationship between fine particulate exposures. And they've now looked at a lot of different outcomes, cardiovascular specific mortality, different pulmonary conditions. You can see COPD there. And then since then, a lot of other cohorts have been run. These are all of these are really well-designed prospective cohorts, large, and we don't have time to go through all of them in detail, but they've really deepened our understanding of this relationship between PM 2.5 and health, and given us evidence for specific cardiovascular outcomes like ACS and stroke, arrhythmias, heart failure, cardiovascular hospitalization, and of course, mortality. Here at Mount Sinai, we've thrown our hat in the ring as well. We have a cohort looking at 8 different environmental risk factors, including air pollution, and looking at the impact on cardiovascular mortality. This cohort is about 50,000 individuals, followed for about 11 years now in Golistan in Iran. And very proud to be part of this project. It's NIH funded, and we're always looking for interested people to help us crunch numbers. So let me know if you're interested. Yeah, let's jump into mechanisms. So based on all of these cohort data, there's been a number of bench-based studies that have looked at the mechanisms in animals and then ultimately in humans. And all of that work is sort of summarized in this figure. So first, when you inhale air pollution into the lungs, and here it enters the systemic circulation, and you get inflammation both at the lungs and then at remote sites, which leads to oxidative stress and the activation of prothrombotic pathways, and also sometimes acting on neural receptors, causing neural reflex arcs, autonomic imbalance. And the chronic exposure to this kind of low-grade inflammation ultimately leads to the development of traditional cardiovascular risk factors like high blood pressure, insulin resistance, hyperlipidemia, endothelial dysfunction, ultimately atherosclerosis, and also diffuse myocardial fibrosis. And then acute exposures to PM 2.5 can also trigger rupture of pre-existing atherosclerotic plaques. You get an increase in platelet activation. Again, like I said, prothrombotic pathways go up. You get decrease in fibrinolysis, endothelial dysfunction, and so you can get a destabilization. Sometimes people who've never been exposed to air pollution in the past, if they have bad CAD from another cause and then they're exposed to high air pollution exposures, that can harvest the plaques that are already there. So you don't necessarily have to have been exposed to air pollution for a long time to suffer from an exposure. And ultimately, this atherosclerotic burden, of course, leads to the outcomes we see: high rates of ACS and MI and mortality. A recent American Heart Association statement estimated that on average, the relative risk of all these outcomes increases about 1 to 2% for short-term exposures to air pollution, or about 5 to 10% for chronic exposures. That's per 10 micrograms per meter cubed exposure of PM 2.5. And these associations appear to hold up regardless of where the air pollution is coming from, whether it's wildfire smoke or traffic, indoor or outdoor, etc. A lot of the early work on these mechanistic pathways was done here. This is a key study that showed how air pollution exposures can really accelerate atherosclerosis. This is a team that included Dr. Fuster and some others that looked at changes in aortic plaque area in response to PM 2.5. And they saw significantly larger aortic plaques with increased lipid content, increased macrophage infiltration, and exaggerated responses to the administration of vasoconstrictors in mice that had higher exposures. One of the studies I'm involved in right now that's ongoing here at Mount Sinai is looking at the association between air pollution and non-ischemic diffuse myocardial fibrosis that can then predispose individuals to heart failure, to diastolic dysfunction. And this has been shown in mice, but it's never been shown in humans. So we've developed a database of a couple thousand MRIs. We're looking at the environmental exposures of those individuals based on their home address. We can show what levels of air pollution they've been exposed to see if we can find an independent association between air pollution exposures lifelong and the development of this diffuse low-grade fibrosis in the heart. And as all of this evidence has mounted, we've started to see different societies release statements, important consensus documents about air pollution. So this is from the AHA, where they, in 2010, had this comprehensive review of the literature and concluded that there's a causal relationship between PM 2.5 and cardiovascular mortality. And it's really one of the modifiable risk factors for cardiovascular disease. And the ESC followed in 2015, also writing that air pollution is causally associated. So if air pollution is a modifiable risk factor, then how can we modify it? So I want to talk a little bit more about some of the interventions that are coming out, both at the population level and in the individual level, and how this may affect clinical practice. And I think it can serve as an example of environmental risk in general and how we as clinicians can think about it. So first, I think the two barriers for incorporating the environment into bedside practice is, one, how do you even know what the environmental risks are for the patient in front of you? And then number two is what can you do about it? So in terms of risk assessment, I think just to frame it, I don't think that this is as foreign as we think. We already ask a lot of basic questions about smoking or dietary patterns. to help us risk stratify and to be easy to incorporate some environmental questions. This is a clinical screening tool that we published in Circulation, covering some of the key predictors for air pollution exposure. This is more targeted for a developing world setting. It's currently being field tested by clinical health workers in Ghana. But you can see it's just asking about common exposures to air pollution in that environment. And, for me, clinically, I'm starting to incorporate these kinds of questions into my practice as I'm becoming more familiar with the different exposures we see around the world. I mentioned how high air pollution levels are in Dhaka and New Delhi. If people are from those areas, I ask them about their housing, about whether, where in the city they were living, if they noticed whether they're exposed to air pollution. If I have a patient new from Malawi or something who grew up their entire life there, I asked whether, they spent their life cooking indoors over solid fuel stoves, etc. I think you learn another dimension of the patient and another dimension of their health when you ask these questions. Oftentimes, we're not familiar with where someone is from and what the risks are in that location. So then you can turn to risk mapping and exposure mapping. There's a lot of these exposure maps for many different environmental risk factors that can give you a sense of what the environmental risks are at any location. And a lot of these maps have been developed here at Mount Sinai, where I think arguably we have the best pollution geographers in the whole world. So, you could plug in a patient's home address into a map like this and get a sense of their exposures. The next step beyond this is going to be personal monitoring, and I think we'll see this more and more in clinic, particularly in richer countries. And this isn't an endorsement for any of these products, but just to kind of give you a sense of what's out there and what's coming. So Apple Watch can now link your location to an exposure map to tell you what the current air pollution level is. You can get alerts on this on your phone and your iWatch. A lot of different apps do this for all the different platforms. And you can see these are really popular apps. This one on the bottom has like 182,000 reviews. And then a lot of these apps, then after they tell you you're being exposed, they try to give you recommendations on things to do. And patients have questions about those recommendations, and those recommendations may be inaccurate or not appropriate for that patient. So it starts to raise a lot of questions that doctors may need to get answered. You may have, in cardiology, we see all the time people now with iWatches come in. They told them they had an arrhythmia, their heart rate was 200 yesterday. What does this mean? And I think the next step is going to be these kinds of environmental questions. Some companies have developed wearable pollution monitors that quantify personalized exposures. Sorry, let me put that phone on hold. This was just to show you some of the other technology that's coming out. These are wearable monitors that actually have sensors on them, so you can know your exact level of air pollution where you are, rather than linking to an exposure map. And a lot of the major telecommunications companies like Apple, for example, hold patents for these kinds of devices. So I think we'll start to see environmental sensors being built into a lot of our personal electronic devices for air pollution, but also for things like for heat exposure, for example. And then, once we know these exposures, we can start estimating what it means in terms of a patient's risk. So every environmental risk factor have exposure response curves. These are the ones developed for air pollution and ischemic heart disease and stroke. These are pretty well validated at this point. They tend to be more applicable at a population level, but that individual data is we're trying to develop. You can apply an exposure response curve like this to an exposure map to get a risk map. So this is the relative risk of IHD mortality, ischemic heart disease mortality attributable to PM 2.5 in New York City in 2014. And this was published in Circulation. And you can see that there's elevated risk in the highest density regions, as well as along major roadways like I-95. You can kind of see curving its way across northern Manhattan and the Bronx there. Some researchers here at Mount Sinai are interested in making this information available through the EMR. I'm kind of excited about this. And anything that lowers the barrier to give clinicians information. This is a mock-up, but here you can see that we're using a patient's home address to categorize them into different risk categories based on their environmental exposures. So you could do this with air pollution. You could do it with other risk factors like drinking water, food deserts, proximity to PCI centers or primary care, extreme temperatures, etc. And this kind of thinking probably will also become important in the era of accountable care organizations, because now a hospital can understand where its service population is. It can look at what the environmental risks are affecting that service population and can direct resources to care for the most vulnerable groups. And that kind of prevention, can save admissions, and through the ACO model, save money and increase profitability for a hospital. So these kinds of conversations are being had more and more. There's talk about incorporating air pollution into some of the common risk calculators that we have. You're probably familiar with this 10-year ASCVD risk estimator. Again, this is just a mock-up, but showing how we could include an environmental exposure into this kind of more global risk estimator. All of these tools give us a sense of exposure, but that's not the only thing that defines risk, because there's differences in individual susceptibility. And I just want to point out that a lot of the more marginalized groups tend to be more susceptible, and you should keep that in mind when you're looking to risk stratify patients and populations. We see that disproportionate exposures and susceptibility fall on indigenous peoples, on minorities, particularly on outdoor workers, migrant workers, also the elderly, communities of lower socioeconomic status. And oftentimes those groups already have lower baseline health. Often they have fewer resources to reduce their exposures and manage any health side effects. Okay, so let's move from here to talk about really targeted interventions. I should say that as when I present this talk to cardiologists, everyone wants to see the randomized control trials, because that's what we're used to. There are some RCTs in this field, and there are a lot that are currently being funded by the NIH and others. But the evidence base to support these interventions is not quite at the level that some people would expect. But I think it's an exciting time to learn more about what can be done. There's about a dozen or so trials that have tested specific interventions to reduce air pollution exposures, and some of them really are showing promising results. They often focus more on intermediate endpoints, biomarkers and things, rather than hard outcomes like cardiovascular mortality. And often they're focused in areas where the exposures are really high, so they may not be applicable to a place like New York City. They're hypothesis generating, but they're going to be backed in the coming years by larger trials. Let me just give you a few examples of the kind of trials that have been done in recent years. This is let's look at 3 different interventions for air pollution: face masks, indoor air purifiers, and use of a clean burning stove. So this is a trial from China looking at face masks. It's an open crossover trial that enrolled 98 patients with known coronary artery disease. And they had to wear a respirator when they were walking down a route in Beijing. They went through a brief washout period, then they walked the same route without a mask. And they saw that the mask led to small but significant reductions in blood pressure, in ST segment depression, and improvements in heart rate variability. This is an air filtration trial. There have been close to 10 small randomized trials looking at indoor air filtration. This one was randomized, double-blinded crossover trial of 35 college students who were randomized to a functional air purifier versus a sham purifier for 48 hours with a 2-week washout interval and then a switch, and then monitored for 14 circulating biomarkers. And they saw that air purification system reduced PM 2.5 exposures by half, and that there was an improvement in blood pressure, a small decrease in systolic blood pressure. And a meta-analysis of these 10 small randomized trials, including this trial, demonstrated that an indoor portable air cleaner was associated with lower systolic blood pressure by an average of about 4 millimeters of mercury. And I just want to plug here, this is a trial that's funded by our group. We're very excited about it. It's an R01 in India, where we're going to look at the effect of indoor air purifiers. So we have participants living in New Delhi who are going to be randomized to functional versus sham home air purification, and then followed for some hard endpoints of stroke and MI and heart failure exacerbation. And this is really the first large randomized controlled trial looking at hard endpoints and air purification. So stay tuned for results. We're going to be enrolling patients starting this year in India. So, I'll skip here to summary of interventions. Outside of these randomized trials, there's a lot of data to support interventions that reduce air pollution exposures. A lot of these have been summarized nicely in this new AHA statement on personal protective actions against PM 2.5, which I really recommend you check out. In the US, these recommendations are probably most important for the most highly exposed, the most susceptible patients. Just to run through these are things you could offer your patients. Patient education, of course, important always. It shouldn't be assumed that people understand that air pollution is a risk. A lot of people think that things like wildfire smoke, because it's natural, must not be harmful, which is false. People need to understand that it is a risk factor for heart and lung disease. Standard management of just baseline atherosclerotic disease is important to reduce the growth of those plaques, reduce the chance of them being harvested by an air pollution exposure. Personal exposure monitoring is really important for at-risk patients so that they can know when levels are high and they can try to avoid or reduce their exposures. In terms of specific behaviors that reduce exposures, minimizing your outdoor activities makes sense. If you live in a wildfire country, outdoor errands and things should be reduced when exposures are high. When it's wildfire season coming up, making sure you have a stock of essential medications, toilet paper, etc., so you don't have to go outside in August and September can be wise. A question I get a lot is about exercising outside in high pollution settings. And because obviously there's cardiovascular benefit to exercise, but there may be harm from the pollution. And the answer to that is if you don't have any pre-existing cardiovascular disease and PM 2.5 levels are below 100, then aerobic exercise outside, probably the benefits outweigh the risks. If it's above 100, you shouldn't exercise outside, exercise in a gym. And if you're with someone who does have pre-existing disease and air pollution levels are 50 to 100 or higher, then would not recommend outdoor exercise. Air filtration, we talked about a trial and a meta-analysis that have shown the benefits of this. There's really two big ways to filter your air. First, in big buildings like our hospital, you need specialized HVAC, mechanical ventilation with fitted HEPA filters that remove the majority of PM 2.5. And that's been shown to modify the relationship between PM exposure and cardiovascular hospitalization in the US. For homes, portable air cleaners are probably the most protective technology available. You need to have a dedicated space in your home, probably where you spend a lot of time, where you can isolate it from the outdoor environment, turn on your portable air cleaner, and spend time there. And a modeling study found that if PACs, portable air cleaners, were adopted widely across the United States, the reduction in PM exposure would probably prevent about 60,000 premature deaths annually. Let's see, jumping to face masks. So an N95 can really reduce PM exposures if they're well fitted. It's funny, this is not an intervention that anyone in this community thought the world would accept, 5-10 years ago. Couldn't imagine asking people to wear face masks all the time, but it is effective at reducing air pollution exposures when they're high. Talked about having a clean air space at home. If you don't have access to a clean air space at home, then there are clean air shelters in New York City and elsewhere, malls and things that have HVAC systems that are cleaning the air where you can get away from outdoor air pollution. Automobile modifications, if you're spending a lot of time commuting on the roads where pollution is high, Having a HEPA filter in your car can really reduce the pollution levels inside. Turning air filtration to that circular arrow that recirculate can reduce air pollution as well. Closing your windows, closing your sky roof. And then broader policy considerations, of course, are going to be important. We need regulations and taxes and penalties and offsetting programs to reduce industry and traffic emissions. The U.S., these kinds of interventions usually pay for themselves, I should say. The U.S. Clean Air Act, for example, has probably generated about a 30 times economic return on the initial investment just by reduced hospitalizations, improved productivity. And, we can also focus in the healthcare system on adopting high impact behaviors that mitigate global health greenhouse gas emissions and improve cardiovascular health. So things like replacing a red meat diet with a plant-based diet, of course, has cardiovascular benefits, but also significantly reduces greenhouse gas emissions. Replacing automobile transportation with active transportation has co-benefits as well. So they're real high-impact interventions that can be prioritized. All of these different interventions were recently put together into a simple algorithm in that New England Journal article that I mentioned by Drs. Landergan and Rajagopalan. So just to run through this, this is something that you could use with your patients. So the clinician just first performs an assessment of an individual's air pollution exposures. If you have a susceptible patient, like someone with pre-existing cardiovascular disease, and daily PM2.5 exposures are above 35, then the doctor can recommend specific interventions. And if daily exposures are very elevated, like you might see in a wildfire event across the West Coast, or even when smoke comes east for us, then all individuals can be candidates for those interventions, not just those that have pre-existing cardiovascular disease. So just to kind of apply that to clinical practice in New York City, you can use an exposure map like this one to estimate, like I said, where somebody lives. About half of New York City has average annual PM2.5 levels above 12, and that includes most of Manhattan and the southern Bronx. So for our susceptible patients that have known CVD living in these areas, the recommendation would be to have passive air cleaning with HEPA filters. And this type of air cleaning, I should note, although we see it a lot in our buildings in Manhattan, often is not available in low-income housing. And so this is really a priority intervention, even here where we live. A fraction of our more susceptible patients live in areas where daily exposures may be as high as 35, like in the I-95 corridor. And those patients, as if they have pre-existing disease, should be connected to alert systems that can tell them when the level's exceeding 35. And on those days should, try to remain indoors, consider using an N95 when they're outdoors, use a HEPA air filtration system to clean the air in their home. Okay, I know we're getting close to the hour. That's the end of my comments really on interventions for air pollution. And I hope that gives you kind of a flavor of how we're working to understand that risk factor, to empower clinicians to protect cardiovascular health. And it's really just one environmental risk factor becoming worse under climate change. You could imagine similar integrated or personalized approaches to these kinds of risk factors being developed for things like extreme temperature, for water pollution, for noise, for malnutrition, etc. And that's kind of our goal in environmental cardiology. If you're interested in getting involved, feel free to reach out to me. And I also highly recommend checking out the Mount Sinai Institute for Exposomic Research, which is dedicated to understanding the impact of the sum total of environmental exposures on human health across the lifetime. I hope overall I've convinced you that climate change really poses risks to cardiovascular health. It's going to accelerate over our lifetimes. Those risks are quantifiable, they're modifiable at the individual level, and clinicians like us and our patients can be empowered to reduce those risks. And it's a field with great opportunity. So with that, I'll say thanks very much for listening. And if there's any questions, I'm happy to try to answer.
Thank you, Dr. Hadley, for a very detailed look, and frankly, might I say, sobering look at what's happening, what's coming down the pike. And I'm sure there's a ton of questions. I see Dr. Brown has a question. Dr. Brown?
Yes, I do. Several, in fact. I wonder what we know about the cumulative effects of the high particle exposure, because it waxes and wanes, obviously, it depends on day. And then what is the efficiency, if there is any, of the bodies clearing these? And at what level, in other words, if you get more pollution than your body can clear, but if you're less pollution, your body can clear, do we know anything about that? And the other question I have is how to convince the world, because it's really hard when I go up to the Catskills and people are chopping wood to burn to keep warm and cook, and it's cheaper because they don't have to buy fuel from other sources. So how do you help them manage that because of the economic issues? And then finally, the air purifiers always suck electricity, and they also cost something, and
Yeah.
also their efficiency is based on size of the space you're purifying.
Right.
So the
Right.
bigger space, that the bigger the unit you have to have, which sucks up more electricity. I know there are patients who can't use electrical devices at home because the electricity costs go up so much they can't pay their bills. So it's a complex problem. I think it's a wonderful, wonderful presentation that you made, and it's a start to what we need to do. But there's so many factors that go into how we can actually do this.
Absolutely. Yeah, it's early days. All great points. Try see if I can answer all of them. They in terms of the chronic exposures, yeah, it's true, right? Day to day, it's going to fluctuate, and it's really the integral over time that matters in the same way that someone who has a 5-year packing smoking history, they didn't smoke the same number of cigarettes every day. So what we're looking at, we tend to look at is just the average exposure over a year at a specific location. And hopefully that can become more nuanced over time. And that exposure produces a risk of atherosclerotic disease about 5 times as high as an
Right.
acute exposure. So certainly important. Clearance of pollutants is very interesting. It seems like the body is pretty good at breaking down what we inhale. There's some evidence that there may be accumulation in fat and neurons, but it's really exposure in a day or two after inhalation where you get the inflammation and you get the cardiovascular consequences.
Mm.
Okay, so listen, can I ask a quick question? Mike, you spend a lot of time on pollution, but there are other threats that are environmental, such as rising temperatures and so on. Now, just like we've seen, let's say in cardio-oncology, some novel approaches to attenuating chemotherapeutic-induced cardiac toxicity, such as using statins and so on. Is anyone looking at things like that, novel medications or novel uses of current medications in attenuating some of these environmentally induced disasters? Oh, it looks like we've lost Dr. Hadley. Well, thank you all for attending. I hope this was a little thought-provoking, if not scary. And I'm sure we'll have him back in another year or two to tell us where his work is going. Thank you all. See you in a minute or two at the Critical Care Committee meeting.